Welcome to Kaiju Mathematics. Today I will be looking at independent events. Independent events are events where the probability of that outcome has not been affected by the previous experiment before it. So the best example that I could give for that is rolling a dice, flipping a coin, those kind of experiments. Where if I roll a dice and I observe the outcome, I pick up the dice, I roll it again, the outcome doesn't care what just happened on that previous roll. So it's possible that I roll 100 ones in a row. It's probably not gonna happen, but it's possible. Like, it could happen. In a crazy world, it could happen, but it probably won't. Very, very, very unlikely, but it could happen. We don't care what happened on the previous roll. The dice doesn't know that the probability of getting a 1 is a 1 out of 6, so it better get all the other sides. It just happens. But we could get 100 ones in a row. Just not going to happen, though, realistically. So when we're looking at independent events, what we want to think of it as is multiplication. So what I want to look at is I'm going to have the experiment of rolling a dice, fair dice meaning all 6 sides are evenly as likely to happen, even probabilities, 1 out of 6 for all 6 sides. I'm going to look at the probability of rolling a dice and flipping a coin. So these are the two experiments that we're going to take a look at here. On the dice, let's say we want to roll a 3. On the coin, we want to flip heads on the coin. These two events are independent of one another. So what is the probability of rolling a 3? The probability of rolling a 3 is 1 out of 6. There's one side on the dice that is a 3 out of 6 possible sides, times the probability of flipping heads on the coin. How many sides on a coin are heads? One side out of 2 sides on a coin. So 1 out of 6 times 1 out of 2 is 1 out of 12. So of all the outcomes that could happen when we roll a dice and flip a coin, 1 out of 12 of those will end up with a 3 and heads. And you could write this all out by actually showing the experiment. Well, I could roll a 1, I could flip heads. I could roll a 1, I could flip tails. I could roll 2 heads, 2 tails, and so on. And what you'd end up with is when we get to 3, so 3 heads, 3 tails, that happens one time. 2, 4, 6, 8, 10, 12, 4, 5, and 6, one time out of 12. See? There's this more visual approach of it, of actually mapping out all the possible outcomes. And then there's the more multiplication route of just looking at it as a multiplication problem of saying probability of rolling a 3, 1 out of 6, times probability of heads, 1 out of 2, and you get 1 out of 12. Now, what else can we do with this? Let's look at the experiment of I want to, using kind of a version of that rolling a 1 100 times in a row. Let's say I'm sitting there in class one day and I'm just bored and I'm flipping the coin and I want to know what is the probability of observing 5 heads in a row. So another way of doing this, rather than writing out 5 heads in a row, so rather than writing out 1 heads times 2 heads times 3 heads, 4 heads, and then 5 heads, this isn't terrible. But what if I tacked on a 0 here? 50 heads in a row, or 500 heads in a row, or just bigger numbers where I don't want to write this out a bunch of times? What we can actually do is just raise this to the exponent. So if I want the probability of a head, and I want that to happen 5 times in a row, 1/2 to the 5th, which is going to be 1 over 32 is one way we could write that. I was going to convert that to the decimal here, which is, so this is going to be 1 out of 32, which is 2 to the 5th, and then the decimal is 0.03125. And you could do that with anything. You could do that with rolling the dice. If I wanted to roll 6 3s in a row, probability of rolling a 3, 1 out of 6, and I want that to happen 6 times, so 1 out of 6 to the 6th, which is going to give us a pretty small number, and it's actually 0.00004 zeros 214. Just write that out there. But those are independent events. You just want to multiply probabilities together because the previous outcomes are not affecting the next experiments. If you like this content and you want more math and Calcudoku puzzles in your life, please hit that subscribe button, and thank you for watching.